horizontal plus coil, it is called as also armature. And this is also called as this is nothing but it is called as armature. So that is the rectangular coil is there which works as the armature here. Now the coil is placed between the two poles of the magnetic field such that the AB and CD are perpendicular to the direction of the magnetic field. These are the two magnets are there. AB and CD, they are perpendicular to the direction of the magnetic field. So here we will place it such that AB and CD perpendicular to the direction of the magnetic field. Magnetic field is there as it is moving in this direction, and so it is a perpendicular to the AB and CD. It is a perpendicular for the direction of the magnetic field, and this we are going to place here. The ends of the coil are connected to the two holes of the PQ split rings. So here there is a P and Q split rings are there we are taking. See, first of all simple arrangement. As these magnets are there, these two magnets with the coil we are rectangular coil we are taking first of all like this. This is the coil we take. This is a simple arrangement is there for the electric motor. Now, as you know, whenever current is flowing through the circuit, we imagine current flowing through the circuit. This is the current carrying conductor, rectangular coil is there, and when we are giving the current is flowing through that. That time, because of the here direction of the magnetic field is there, it is moving from like this direction of the magnetic field is there. So when direction of magnetic field, when current and conductor both come in contact with each other, there is a formation of the force, and when force is the forming, this is the magnetic field direction, this is the current carrying conductor, and so there is a formation of the force, and this starts to rotate. See, this conductor is there, this aluminum conductor is there, which is a rectangular coil is there. It starts to rotate in one because of the force, as we saw here in this experiment. We saw that because of the force of the, because when current carrying conductor and here magnetic field of the magnet when both come in contact, that time there is a formation of the force and there is a motion. We saw movement of the here conductor is there, it is taken place. So now we are observing here movement is there in the conductor. Only imagine first of all how here it is there we saw in this activity, like that here it is there in this activity also. So in this activity as we observed here, there is this current carrying a conductor is there and magnets are there. Magnet is there always moving, the direction of the magnetic field is there from the north to south it is there. So this is the direction of the magnetic field is there. This is the direction of the current is there which is in the flowing in the rectangular coil. This is nothing but a rectangular coil is there. One wire is there. Imagine that first of all one wire is there. Through that wire current is flowing. And these are the magnets. Now as magnetic field when come in contact with the current carrying conductor, there is a formation of the force, and so because of that force here this rectangular coil is there. It starts for rotating. So like the this is the rectangular coil is there, and this rectangular coil it starts to rotate when there is the magnets are there, and this is the rectangular coil is there, and when current is flowing through the conductor, that time this rectangular coil it starts to rotate. Where it is rotating, that is also one important here now. In which direction? Like means it is moving in this direction or in this direction, because we saw how the direction of the magnetic field we are changing, otherwise the direction of the current we are changing, reversing like that direction of the here conductor is also rotation is there in clockwise or anti-clockwise it is also changing. So first of all as I told, magnetic field is there, current and conductor is there, and so because of that there is a formation of a force, and when force is forming there is a movement in the conductor, and we take a rectangular coil which has a many turns are there. So there is a force carrying or greater force formation is there. When force will form, now here there is the north side we take on this side and south is the on this side. So magnetic field is there as we are applying here. Plane means the left hand rule. See here magnetic field finger direction of current, thumb represents the force, and when we are applying here, see magnetic field in this direction is there. So forefinger represents the magnetic field. Middle finger represents the direction of the current. Direction of current is this side, magnetic field is this side. So you are observing where is my thumb now? Thumb is the downside. So means there is a rotation or the here movement or the motion of the conductor is there at the downside means this rectangular coil is there moving like this. It is moving like this. So here there is a movement of or rotation is there you are observing. But it is again when it will come to this side. Yes, that time now the change of the direction of the current is there you are observing. So the AB will come go to the that side and CD will come this side. So you are observing that the direction of the current is changing here. Means the rotation is there again like this clockwise. Means one time clockwise, one time anti-clockwise like this it is there. So to avoid this, see what I told you. Direction of current is there. This is the AB and CD parts are there. This is the one arm AB, this is another arm CD. The current is flowing from this side to this and current is flowing from this to this side. That time what will happen? Here AB is there. As I told you, and the left hand will apply. That time here this AB side moves to the downside. And like this there is the now CD will come on the this side and AB moves to that side. Arm CD is there, it comes to this side. But the direction of current which you are observing, the AB direction is there. Here it is upside, the CD direction of the current is there. It is downside. That tendency effect causing, and so again that here armature, this is nothing but it is called as the armature, and this armature again changing means like this it is moving. Now that will moving to the clockwise. So one time anti-clockwise, one clockwise, and there is the coil here. Wires are there. When they are rotating, wire is going to turn and turn, and so because of that there is again confusion is there. So for all avoiding this, here they use here split rings. Yes, that is called as a commutator. A device is used here. It is nothing but a commutator, which is a device that reverses the direction of the flow of current. This is a commutator. Split ring is acting or it works as a here commutator. The commutator is a device which which reverses the direction of the flow of the current through the circuit. Direction of flow of the current through the circuit. Here, that one changing. So, this is a commutator is used here. Commutator means here used as a split rings. Two rings are there. If you are taking a banker and if you are breaking, we are getting two C-shaped rings that are called as two split rings are there. So, here take two split rings that is called as a commutator split rings here. Working as a commutator here. This commutator is a device. It is nothing but which is changing or which is reversing the direction of the flow of the current. For that purpose we are used. As I told, I explained here. For that means it is a basic knowledge. By that we are going to see that here this is nothing but this is armature. Now here giving the connection or connecting that one armature to the split rings. So split ring is nothing but that is used as a commutator. Now split ring here used as a commutator. Commutator means what? It is a device which is reversing the flow or here the flow of the current of the direction is there. It will reverse whenever the armature is moving. That time it will reverse the change of or it will change the direction of the current. For that purpose we are using a commutator. Split ring is used as here commutator. So now split rings are there for the axle. One rod-like structure is there. For that rod-like structure only the split rings are there. Fixed like this on the cylindrical one. Rod-like structure is there. For that there is a split ring is there. It is fixed. It is nothing but for the movement purpose. See how it is rotating. There is a rotating of the axle is there. Means that cylindrical rod is there. That is rotating or fan is there. Electrical energy is there. Now this electrical energy which is moving by the rotation of this armature formation of mechanical energy. So axle is rotating, and so like that there is a mechanical energy form, and the devices are working here. Like a fan is working, and like axle is start to rotating. When battery starts, current will move from the armature, and in that time the armature is working. At that time, what will happen? The electrical energy here, movement of the armature is there, it is going to take place, and that movement is there. Because of that, there is a formation of the means movement is there, nothing but a mechanical energy is formed, and that is using for the like fans, refrigerators, washing machines, otherwise other different devices are there in that they are going to use. So these split rings are there. These are C-shaped. If you are taking bangle or any circle ring, if you are making the two cuts in that, you are getting two C-shaped structure that are called as here split rings. So these split rings are there here, fixed here, and for that split ring giving a connection. That is the here you are observing that brushes are there. Brushes are there. Upside only there is a they are joining. They are only attaching for the split ring. This is the split ring. For the split ring there is the attachment of the brush, and through that current is moving. These are independently moving. The brushes are not moving there. Only split rings are there. They are going to move when there is a movement of the armature is there. Only split rings are there independently. They are not. When they are going to move here. When this is the movement of the armature is there, that time this means this is the moving. How? See, imagine this is the armature. Armature starts to rotate. Like that, there is a split ring also rotating. But brushes are there. Only fixed brushes are not moving. Yes, here there is you are observing X, Y are the brushes you are going to here observe. X, Y is called as here brushes are there, and P2 are there. Split rings are there. We are observing here. So here the coil is placed between the two poles of the magnetic field, and such that AB and CD perpendicular to the direction of the magnetic field. The end of the coil are connected to the two halves P and Q that are called as here P and Q split rings. The end of the coil are connected. This is the end of the coil which is connected for the two halves, and that are called as split rings P and Q. Now the inner side of these halves are insulated and attached to that, and so as I told you, the axle is there, inner half of that insulated split rings are there that were attached. It is insulated one. Insulation means they are not conducting electricity. They are insulated one here, and they are attached for the axle. Now here the and to the axle, the external conducting edges of P and Q touch to the two conductor stationary brushes, that is X and Y. So externally these split rings are there. They are attached for the brushes, that is X and Y. Brushes are there for the both sides for the split ring. Here one brush and here is the for the split ring another one brush is there. This is the split rings are there, and for the split ring like this arrangement is there. That are the X and Y brushes. P and Q are there. They are the split rings. X and Y, they are the brushes are there. They are touching for that. Here P and Q touch the two conducting stationary brushes are there. They are stationary one. Brushes are not moving. Only P, Q split rings are there moving. X and Y brushes are there. They are stationary. They are fixed here. Only split rings are there. They are going to move like this. So current in the coil electricity enters from the source of battery to the conducting brushes X and flows back to the battery to the Y. See here current is there in the conductor. It will move from the X and flows back to the Y. So like this current is when battery starts and switch on the P, that time you are observing that current is flowing to the X and moving again to the battery to the conducting brush here. So here to the X and flows back to the battery to the brush Y, and it will come out. So current moving like this, then like this it is moving from ABCD rectangular coil, that is armature, and from that again it will come from the one, and this is the complete circuit is there. So notice that the current in the arc AB of the coil flows from A to going from A to B, then from B to C, then again from C to B. See the direction of current, it is from A to B. Here direction of current is there from C to B, it is there. So here you are observing that there is a movement, motion is there. As I told you, magnetic field is there like this. Direction of the current is there that you are observing. This is showing the direction of the current, and you are observing that force is applying, and force, because of the force there is the here this arm is there moving downwards. So moving this arm. First of all, take this arm in your mind. It is moving downwards. But this is moving upwards. Now how it is moving upwards? Current, magnetic field is there, as you know, from north to the south is there. So magnetic field in this direction, and current is there flowing in this direction. And as you know, here thumb is upwards. So there is the armature is there, or this ABCD coil is there moving up. First this arm, because of the direction of current is there this side, it moves down, and here this will move, that arm is there, it moves, CD arm is there, it moves up. There is a force will come on this conductor also and on this conductor also, that is because of the magnets, current carrying conductor, formation of the force. When we apply flame left hand rule for this arm and flame right hand rule for this arm, you are observing that here direction of the current is there, that is upside is there AB, and here magnetic field and force is there, it is applied, it is moving the downwards. So because of that, arm AB moves down, and here you are observing that this is the direction of current, force is here, direction of current, magnetic field in this direction, and as you know, force applies moves upside, and so there is the ABCD armature is there, it is moving like this. This arm AB, this arm CD. AB arm moves down and CD arm moves up. So magnetic field, that left hand rule, you should apply there. So notice that the current in arm AB of the coil flows from A to B. The current is moving from A to B, as I told you. In arm CD, it flows from C to B, and in arm CD, the direction of current is there, it is changing here. So CD, it is here, that is opposite to the direction of current to the arm AB. See, the direction of current of arm AB is there in this direction, but CD arm direction of the current is there opposite to the arm AB. On applying Fleming left hand rule, so as I told, apply the Fleming left hand rule here. Here, direction of the force of the current carrying conductor in a magnetic field. Here, direction of the force of the current carrying conductor in a magnetic field. When we apply here, then we find that the force acting on arm AB pushes downwards. As I told, arm AB is there. This is the arm AB, this is the conductor, this is the magnetic field which is moving in this field. Magnetic field always moving in this direction. The direction of the magnetic field is there. This is the direction of the current is there. The force which will form, see, direction of the current, magnetic field, and this is the force. So arm AB moves downwards. Arm AB is there, it is coming downwards. So if this is arm AB, it will come downwards. Force is there. You are observing that thumb represents force, and here thumb represents force. You are observing that it is moving downwards. So here, then we find the force acting on arm AB pushes me downwards. Arm AB is there, it moves the downwards side. The force acting on arm CD pushes upwards. When we are applying here, Fleming left hand rule, see thumb directed towards the upwards. This is the magnetic field, this is the current which is flowing, and you are observing that there is the here force is applying, or force is going to upwards, and so CD arm pushes upwards, AB arm pushes downwards. So because of that, you observe that here CD arm is there. This is AB arm, this is the CD arm. AB arm pushes downwards, CD arm pushes upwards. Like this direction you are going to observe here. Thus the they are mounted freely. They are only touching the air for the brushes and they are freely rotating. See, here when it will come up, that time the rotation is there of the split rings with that it is taking place. With the here armature or with the conducting wire. CD arm will come this side, AB arm goes that side. That time current direction is there automatically for the CD. When imagine now, see, this is the C and D, this is the A and B. So when AB is this side, that time direction of current upside, and CD this side direction of current downside. Now again CD will come on this side and AB moves that side. Direction of current is automatically changing because of the split rings. The split rings are there, they are rotating and the current as it is moving and so because of the split rings it is rotating itself. Means like this there is a rotation itself it is going to take place because split rings are there with the help of that attached and these split rings are there, they are rotating here freely, mounted freely, and so because of that here there is a direction of the arm CD. Again it is as it is as for the AB and here for AB it is again changing. First time it is AB arm has the direction upside. Now here AB arm has the direction here downside. So direction of the current is there, I am telling you. Arm is there, it is rotating, that time it is moving in an anti-clockwise direction completely because of the split rings we used here. Thus the coil and the axle O, coil, this is the coil and this is the axle which we used here. Thus the coil and axle O is there, mounted free to turn about that axis. They are mounted freely and they turn about that axis. They are freely rotating. Rotate in an anti-clockwise direction and it is rotating always in an anti-clockwise direction because we use here commutator, that is the split rings. Commutator is a device which reversing the direction of the current. So here there is a reversing the direction of current of the arm. CD when come this side, that time there is a direction of the current. It is reverse itself, that is called as a commutator. So split rings are used as a commutator. So here therefore the current here in the coil gets reversed and flows along with the DC DN. So the current is again flowing from DC and sorry here it will come B A. So the current is there how from A B C D it is flowing. When A B C D it is flowing, when arm is AB arm this side, CD arm this side. So AB is there when it is anti-clockwise direction. AB is here and sorry AB is here and CD is there on that side. That time automatically what will happen? This arm AB is there moving on that side and CD will come this side. So now CD is on this side and AB is there on that side. So there is automatically DCBA arms are there. It will come because of they are mounted freely, that is the coil and the axle, and so they are rotating freely and the direction of the current is there reversing here with the help of a commutator. So at half rotation Q makes contact with the brush X. Here brushes are there, they are attached, they are not rotating, they are fixed there only, they are not rotating, only split rings are rotating, brushes are fixed right here. So after the half rotation means what? Half rotation means this one, AB is this side, CD is on this side. When half rotation will complete, when the rotation is there, AB are moving and half rotation is completing. Now AB arm this side, CD arm this side. So CD and AB arm is there. When half rotation is completing, Q makes contact with the X brush. Q split ring is there. Now come to the here and P split ring is there. Come to that side. Means as I told the split rings are rotating. The brushes are not rotating. Brushes are fixed over there. X, Y brushes are fixed there. So when after the half rotation Q makes contact with the X brush and P contact with the Y brush. So therefore the current in the coil gets reversed. So current in the coil is also reversing because split rings are rotating. Split ring, first of all P split ring is there. See here if you before what will happen? AB this side, CD on that side, that time split ring come this side and AB arm goes on that side by the anti-clockwise direction. Why anti-clockwise direction? As we saw, planning left hand roll, force acting on a AB arm, that time it pushes the arm AB pushes downwards, arm CD pushes upwards, and so because of that anti-clockwise direction is there. So in that anti-clockwise direction is there, that time in the first time there is a P brush here. P between this contact with the X brush in the first rotation. This is the first half rotation. So first half rotation is there, that time P splitting is in contact with the X and Q splitting is in contact with the Y. But when this arm after half rotation completing, CD arm will come this side and AB moves that side, that time automatically here splitting Q is come in contact with X and splitting P is come in contact with Y, because XY brushes are there only splittings are there, they are going to move. So after half rotation, Q makes contact with X and P makes contact with the Y. Here, and therefore the current is here and the coil gets reversed. So automatically current in the coil, because splittings are moving, current in the coil is there, as it is for the CD